All right. Hello, everyone, and welcome to this video, Math Made Easy with Terry in 10 minutes. Okay, so we're going to do the last part of integrating with partial fraction, but this time is going to be with quadratic factors, okay, with quadratic factors. And like I told you in the previous video on partial fractions, so if you have a quadratic fraction like this, it's going to be a over x minus 2 plus bx plus c, okay, if it's a quadratic factor, x squared plus 1. Is that okay? So for quadratic factor, you're going to add this part, bx plus c to it. Okay, that is it. Then you start solving now, and this is the easy part. Then you have x squared will be equal to be a x squared plus 1 plus bx plus c x minus 2. Okay, so for it to be x minus 2, then we have to now look at how to make this. So if you put x is equal to 2, this all we go. So that means, so let x to be equal to 2. So that means it will be 2 squared, it will give you 4. It's equal to 2 squared, it's going to be 4 plus 1, it's going to give you 5a. Can you see? So therefore, a is going to be what? Divide both sides by 5. It's going to be 4 over what? 5. Now, the next one I can find now is to find the coefficient of x squared. So I can look for the coefficient of x squared. And that will give me coefficient of x squared here is going to be 1. It's equal to a plus x squared here is going to give me b. Okay. So if you check, we already have a to be 4 over 5. So b is going to be 1 minus a, and that will give you 1 minus 4 over 5. And that will give you 1 over what? 5. Then when we're done with that, the next one we then have to find is coefficient of b. So remember I told you when we're saying coefficient of b, okay? B is we're talking about in terms of ax squared plus bx plus c. So you have to go back to my previous video and have a look. Now, I've done the coefficient of x squared already here. So the coefficient of b is this b we're referring to. So we're going to find the coefficient of what? B this time. Okay? So, like I said, to make it easy, I'm going to rewrite this equation, but I'm going to open this brackets, okay? So I'm going to rewrite this as well, but this time I want to open this other bracket here. I'm going to open this one so that you can see the coefficient of b there. So it's going to be x squared is equal to a, okay? Ax squared plus 1 plus, if I open this bracket, it's going to be bx times this is going to give me bx squared. Bx times this is going to give me minus 2bx, then plus cx, and minus 2c. Then it's going to give me, so if you now have that sorted, then with x squared will be equal to a x squared plus 1 plus. Now, what's common here is x, so it's going to be bx squared. What's common x, so it's going to be plus x into bracket minus 2b plus c, then minus 2c. So you can see the coefficient of x squared here is b. That was why we had b here. Now, coefficient of b now is minus 2b plus c. Can you see? And so that means we can now say coefficient of b now will become, here is going to be 0, but there's no b here. It's equal to, for a now, a is going to be 0. Then for b here is going to be minus 2b plus what? C. So therefore, I can now say, therefore, c, we're then taking b to the other side. So c is going to be equal to 2b. We know our b already to be 1 over 5. So that means it's going to be 2 times 1 over 5. And that will give me what? 2 over what? 5. So we're done with the partial fraction. So we can now write it again. So for the partial fractions, so our a is equal to 4 over 5. The b is equal to 1 over 5. And the c is equal to 2 over 5. Now, going to the next page, I'm going to try to solve it now. So putting it back, so we have x squared divided by x minus 2, x squared plus 1 equal to, so we know the a, we're told the a was, going back to the previous page, a was 4 over 5. So that means it's going to be 4 over 5 divided by x minus 2 plus the b was 1 over 5. That's going to be bx. So it's going to be 1 over 5x plus the c was, what was the c again? 2 over 5, right? The c is 2 over 5. So that means it's going to give you plus 2 over 5. Both of them x squared plus 1. Sorry. So I can rewrite this again. So we're integrating each of this, right? So I can rewrite this again to be, I'm integrating 4 all over 5x minus 2 plus, I can break this into 2 plus 1 over 5x over x squared plus 1 plus 2 over 5 over x squared plus 1. Can you see? Then this is going to give me, I'm integrating 4 over 5x minus 2 plus 1 over 5 x over x squared plus 1. So 1 over 5 is going to still give me x, right? Then plus 2 over 5 x squared plus 1. All right. So the next step, you bring out the constant. The constant here is going to be 4 over 5. You're integrating 1 over x minus 2 plus, bring out the 1 over 5. You're integrating x over x squared plus 1 plus, we're going to integrate, we're going to bring out the constants first. 2 over 5 into bracket 1 over x squared plus 1. Okay, good. Now we're done. So when we integrate this, it's going to give us 4 over 5 ln x minus 2. Now, if we differentiate 2x, x squared, it's not going to give us x, okay? So because of that, I'm going to do this separately. So I'm going to integrate this separately on the next page and bring the answer here, okay? So that is x over x squared plus 1. So we're integrating x over x squared plus 1. So what method do you think we should use here? We can use any other method. I can decide to use substitution. I can decide to use any of the part, but I'll prefer to use substitution here, okay? So I will now say let u to be x squared, so this is dot dx, okay? X squared plus 1, okay? Then we have our du over dx is equal to 2x. So therefore, dx is going to be equal to, the cross multiply, it will be du over 2x. So we're using the substitution method. So in case you've not reviewed me substitution method, please make sure you go back and have a look. So I'm going to substitute this back into the original equation now. So it's going to be x divided by x squared plus 1 is u, and dx is the same thing as saying du over what? 2x. So this cancels this. So we're going to be having integrating 1 over u du. Can you see? 1 over u du. Now, when we have 1 over u du, then this is going to give you, when you integrate 1 over u, so it's saying integrating u raised to power minus 1 du. So it'll be u. You have to add, or you can put it this way. A quicker one. When you integrate, remember I told you when you integrate 1 over x, it's going to give you ln x, right? So when you integrate 1 over u, what do you think it should give you? It's going to give you ln u. and that will give you ln u plus c. And we know our u was x squared plus 1. So it's going to give you ln x squared. Sorry, don't forget to put the 1/2 outside here, okay? So it's going to give you ln 1/2. Okay? And the u here is x squared plus 1 plus c. Okay? So that means the final answer now is going to be 1/2 ln x squared plus 1 plus c. Okay? So, as usual, you differentiate this, and you got 2x, then you have dx, because you have to substitute all the x to make them u. Dx is the same thing as du over 2x. Du over 2x, this is 2. We bring the 2 out there, so it'll be 1/2, 1/u. When you integrate 1/x, it's called ln x. So 1/u is going to give you what? Ln u. Bring the 1/2 out, and we have our u to be x squared plus 1. So then I can now say that is equal to 1/2 ln x squared plus 1 plus c. So I can rewrite it here. It will be 1/5 multiplied by 1/2 ln x squared plus 1, okay, plus c, okay? Now let's solve the other one. 1/x squared plus 1 is going to give you the same thing, okay? Because they are both 1/x squared plus 1. So we go there. So we have another one. We have 1/x squared plus 1. Okay, we're integrating this. So the same thing, let u to be x squared plus 1. Now, if you use let u to be x squared plus 1 here, you see that you're going to get into a fix. Because if you use let u equal to x squared plus 1, then you have du over dx to be equal to 2x. Then you see you're not really solving anything. You can't cancel all the u, okay? So usually the method I prefer to use is, this is one of the special cases of substitution method. I prefer to use let x or x or u to be tan theta, okay? Let's assume this is tan theta. So, and because of that, I also know that theta will be equal to the tan inverse of x, okay? All right? So because of that, I know theta is going to be equal to tan inverse of x. So we also know that dx over d theta will be equal to what? Sec squared x. Okay? So, or sec squared theta as the case may be. So therefore, I can now say my dx is going to be sec squared theta dot d theta. Can you see? So then I can now substitute the whole of dx with what? Sec squared theta dot d theta. Okay? Then, and I can also make it now, I'm integrating 1 over x is what? Tan theta. So it's going to be tan theta all squared plus 1 dot dx is going to be sec squared theta dot d theta. Can you see? And this is the same thing as saying we're integrating 1 over tan squared theta plus 1 multiplied by sec squared theta d theta. But you know, one of the trig identity that tan squared theta plus 1 is equal to what? Sec squared theta. So I can rewrite this again as I'm integrating 1 over sec squared theta dot sec squared theta dot d theta. This will cancel this, so you can see. So remember I told you substitution method, the aim of everything is to remove all the x and substitute with a new variable. So now I can see, you can see from here that I've substituted it with 1 d theta, okay? And therefore, if you integrate 1, it's gonna give you what? Theta. It's gonna be theta plus c. But you know, from the initial one, theta is equal to what? the tan inverse of x. So that means I can write this again to be what? 1 over tan what? X. Or you can just leave it as a tan inverse of x if you just want it easy. So that means when you integrate, it's going to give you the tan inverse of what? X plus c. That's the final answer you get. So now we can go back to this place, and it's going to be 2 over 5 into bracket the tan inverse of what? X. Yep, and that's the final answer. So you can, if you want to simplify further, it's going to be 4 over 5 ln x minus 2 plus 1 over 10 ln x squared plus 1 plus 2 over 5 tan inverse of x plus c. And that is the answer for this question, right? And that's the answer you're going to get for that, all right? Okay, so you can go back, watch the video again, look at it again. And if you're having any questions, feel free to drop me an email, okay? Or try and drop in the comment section, and I'm going to respond to you about it. All right, so the next video I'll be talking about integration of trigonometric function, okay? And I think I'll have two videos more in this series, and I'll be that for that. And please, if you make sure you go back to the textbook, read more, and make sure that we solve more questions on it. And if you have any questions, please let me know. Thank you very much, and I'll see you in the next video.